3-2, solving quadratic equations by graphing. Okay? So, that's basically why I said what I said. This lesson shouldn't be too terribly rough because, you know, we've done this already because we went and did graphing the other day. So, most of this should be pretty much review. The only part that's not going to be review is the little intricacies about, we're going a little higher today, right? We're going to take a couple more steps as far as our parabola studies and stuff like that, okay? So we start off with some equations. Everybody get titled down? Yes? Yeah. Solving quadratic equations by graphing. Okay? Yeah, some of it you will. Quadratic equations, pretty obvious, right? It's a quadratic function set equal to 0, or set equal to a value. Most often you'll want that value to be 0. Okay? Standard form, you can tell how important it is. They put it in here twice. Okay, in the textbook, they put it in twice. So if you need to write that down, that's fine. If you don't, it is what it is. Okay? Now, the next two definitions are very, very similar. They are very, very, I don't want to say confusing, but it's easy to be, they're easily misunderstood. Let's go with that. So before I go into what those actually are, I want you to look at this. Okay? Here they have an example of a quadratic function. Okay? And remember, the function is in function notation, f of x. Okay? The function is f of x equals x squared minus x minus 6. Okay? You can graph that function, which they do over here on this graph. Here is the parabola of it. And then they tell you over here that -2 and 3 are the zeros of the function. Okay? They're the zeros of the function. That's also, and this is the important part today, where the graph crosses the what? X-axis. X-axis. Crosses at -2 over here, crosses at 3 over there. Okay? So the zeros, definition of 0, I know I went backwards, but that's okay. 0 is when the graph of where the graph of a quadratic function crosses the x-axis at. Okay? So zeros are talking about functions and graphs of functions. Okay? Now they go down in this red section of it, and they give you the quadratic equation. Same thing, right? X squared minus x minus 6, which is the same thing as up here. Yeah. Instead of this one down here being equal to f of x, being in function notation, it's an equation that's equal to 0. Okay? But then when they plug them in and try to figure out what makes these two sides of this equation equal, it ends up being -2, which they do right here, and +3, which they do right here. And those are the roots of the equation. Okay? So basically, what roots and zeros are the same thing. Okay? They're the exact same thing. The question is, what context are you talking about them in? Okay? That's the difference. Zeros are whenever you're talking about a function or a graph of. Roots come from an equation. Alright? Alright, now the nice part. So solve x squared minus 3x minus 4 equals 0 by graphing. Alrighty, to be honest, not going to worry about this a whole lot today. I don't need to see you guys show how to graph this. Okay? I know you know how to graph this. What I do want you to learn is how to do it on your calculator. Okay? And think about this on your calculator ways. Okay, so everybody got x squared minus 3x minus 4 down?
Is it y equals?
Well, this one says equals 0. You need to make sure these equal 0 before you put them in.
Make him do that.
Huh?
Do we still click the y equals button and then type it in?
Yeah.
How do you make
But
it equal 0?
hold on. Everybody, Joe. You need to make sure these equations up here equal 0.
So you put equal 0 also?
No, I didn't say that. These equations up here, you need to make sure equal 0. This one does. Everybody see that?
Oh.
This equation equals 0.
So you gotta solve.
Now.
Show us an example of one without 0.
So whenever you go to your calculator now, because remember up here where it says that f of x equals x squared minus x minus 6, and down here it says x squared minus x minus 6 equals 0, and I said these two are the same thing, right? Remember that? That's why you had to make sure it equals 0, because then you can switch up your notations, okay? So you make sure the equation equals 0. Follow me on this train here. Make sure your equation equals 0, because then it's the same as writing it as a function, and f of x is the same as what? Y. Which is why it needs to equal 0, because you connect the dots, and then you go put it in your calculator. Okay? Makes sense. Fantastic. So y equals x squared minus 3x minus 4. And you hit graph. Alright, now, I used to show the calc way to do this, okay, the calculate way to do this. And we're still going to eventually have to learn how to do that. But for now, here's what I want to show you. If I'm going to find where these two graphs, cross the x-axis at, what's my y value going to be? 0, right?
Yeah.
Y value is going to be 0. So whenever I go to hit second and go to my table, all I got to do is look for your y's that say 0. So negative 1's 1, okay, right here. Everybody see that? Negative 1, 0.
Yeah.
All right. You want your y's, not your x's. Okay. So negative 1 is 1, and then you scroll down a ways, and you find out that it should be 4.
Y will always be 0.
Y should be 0 because that's where you are on the y-axis, right? You're not up or down none.
So we're just trying to find where it crosses the x-axis.
Exactly.
That's what this lesson is?
More or less. Okay.
So we would just put our roots or our roots.
Yes. So the way you answer this. Oops, wrong slide. Solve it by graphing. What were they? 4 and negative 1. That's it.
Oh, simple.
And?
Wow. 4 plus negative.
Okay, now, here is some really important information for you guys, okay? Now, you have to pay attention to how many zeros you're going to have. And that's what this box is talking about, okay? Sometimes you will have one real solution, and that's where your vertex sits on that x-axis. Okay, so the vertex is actually on the x-axis, and you have one real solution. We're going to go into more detail with that one later on this chapter. We're also going to go into more details about the no solution type. Okay, whenever it's like pointing up and it's above the x-axis, or it could be pointing down and below the x-axis. All right, either one of those. And it doesn't touch the axis at all. That's a no real solution. Okay, we'll get into that next week. Most common one is when you have two real solutions. Okay, it's below the x-axis and pointing up, or it's above the x-axis and pointing down, crosses the x-axis 2 times. That's your most common example. Okay, so here's your example of one that doesn't equal 0 right away. All you need to do is make it equal 0. Add some things over, subtract some things over, whatever you want to do, however you want to do it. Okay, so I would just do this. I would just add x squared to both sides and subtract 14 from both sides. Okay, which gives you, and I'm gonna rotate it so my zero's on the right now. Okay, so you should have x squared. You didn't mess with the 6x, so x squared minus 6x, and then 23 minus 14 gives you
0.
9
Plus
equals 0.
So you take away everything, it's just going to equal 0.
Yeah, just make it equal 0 on one side or the other. Okay, it really doesn't matter. Because either way, it should end up being the exact same thing.
Is there going to be is there going to be one like that where, like, if you were to, like, say keep 14 over there and then the other side would subtract to equal 14 and then 14 minus 14 is 0? Or is it, are you always going to solve it so it's 0 on one side?
Well, you're always going to solve it so that it's 0 on one side. Okay. Now, I say that when I said what I said just a little bit ago, that you always get the same thing. It's not fully correct, because if you solve this to the left, and you add 6x over and you subtract 23 over, all these signs will be different. Okay, so you may not get the exact same thing, but what you will get are the exact same zeros. Okay, so it doesn't matter whether you solve it to the left or you solve it to the right, you'll still get the same zeros either way. Okay, Lainey?
So, I just put that in my calculator.
Yes.
And I go down to the y that's a 0.
Yes.
But then, how do you get, like, what do you do to find that? Because the last one wasn't the 0.
Just hang tight. Okay, let me get there. All right. Stone. You had your hand up.
Yeah, it's 1, 0.
There's 1, 0. Good. Okay. So x squared minus 6x plus 9 is what I'm going to go put in my calculator. Maybe. There we go. All right. So x squared minus 6x plus 9 graph. Okay, now, see how this graph, it doesn't cross the x-axis?
Yeah.
Okay, but see how it touches it, right?
Yeah.
Okay, so then you're going to be looking for one y that's 0. Okay, so you hit second, you go table, and you look down here, and it is 3. So the y is 0, so your answer's 3.
So the answer's just 3.
Just 3.
But why was the last one 4 and 9?
Because you had
they
2.
both had 0?
Exactly.
I understand.
Okay, Tenyus.
So like, would that mean like all other parts of that line are like just above 0?
Yes, that's exactly it. So like 3.1 and 2.9, for example, are like just barely above 0. You got to account for the fact that you're only zoomed in so far. Okay, but yeah, the only place that parabola touches that x-axis is at 3, 0. Okay, once you go to 2.9 to 3.1, it's off it slightly, but it is. Okay. Now, I'm going to completely make one up real quick. We need to learn how to do this, all right? Which is a little bit of a pain, okay? So bear with me here. Make this ugly. Minus 6x plus, let's see if, I don't know, I'm going off the fly here, so this may not work, but we're going to try 2. Perfect, okay.
Wait, so what was that? Do you want to split these in half?
Okay, now, how many zeros are there on this graph?
2.
2, okay? It's, what did I say it was, plus 2 instead of plus 9?
You haven't said.
Yeah.
Right, oh, right. X, so if you want to follow along, yeah, so probably, as long, you don't need to write this one down, just put it in your calculator and watch along with me, okay?
Alright.
So x squared minus 6x plus 2.
X squared minus.
Change your plus 9 from the last one to plus 2 this time,
Right.
okay? Now, this is going to be a little messy, okay? And you honestly won't have to do this all that often, okay, from what else we're going to learn this whole chapter.
Because it doesn't go like that.
Right, so you don't have a nice 0, okay?
Sloppy.
Which isn't great, okay? This may come up on a homework, so I want to show you guys this now so you don't freak out.
Did you say it was plus 9?
It was plus 9, make it plus 2. Okay? For right now, I don't care if it's not exactly at a point. I don't care that you know exactly what that point is. Okay? We will eventually have a way to figure it out. All right?
So
But
it doesn't say 0 on the calculator.
it won't.
Oh.
Okay? So here's what you got to do. You look through your table. Okay? And obviously if you know, right, this starts at -10, this is positive 10, right? Okay. All the graphs you get, or at least hopefully most of them that you get, they're going to cross somewhere here. Okay? You're not going to be at like 50 and 70. They'll be somewhere within the 10 by 10s.
That'd be really mean.
That would be really, really rude of them. Okay? And me. Okay? What you need to do, you go to your table, and you still look at your y's. Okay, this is all about knowing where that y is because we want to find where y is 0 because that means you're on the x-axis, and that's what we're looking for today.
So,
Okay, Stone, go ahead.
so like in between 0 and 1,
Why?
because 0 is 2 and then 1 is -3, so it has to cross in between.
Exactly.
So is there like an equation that you have to...
Not yet. You don't. I don't care.
So do
You.
we just put in between 0 and 1?
That's exactly what you
And
put.
then in between 5 and 6?
Whatever else it would be. That's exactly all you put. Okay? Because I do know some of your homework show up nasty. Okay? But notice, like he's saying, notice how your y's go from 2 to -3. If these are connected, which they are, and you need to understand that, that means to go from 2 on the y to -3 on the y, you got to cross the what?
Yeah.
You got to cross the x-axis. Which means at some point in between there, you had your 0. Which means your solution is somewhere between 0 and 1. Okay? And that's all you write, between 0 and 1. That's it.
You don't need 5 and 6.
Well, you do need 5, I mean, as far as that one goes. Okay? And then you go find your second one, between 5 and 6, because it goes from negative to positive again. Yes. Your 1 would be a little trickier to find. You would almost have to just kind of look at the graph itself and just say between 3 and 4 or whatever, because because there would be no sign change that showed up here.
Because doesn't it go, if you look at it, it doesn't like repeat the numbers, so it'll go to a number and then it'll go to the next number and repeat, kind of like this.
Yes,
Because it has this number and then it repeats.
more or less. If your vertex is at a nice place, then yes. But like my honors kids just had a vertex of 3/4. You know, so they were 3/4 away from one whole number, but only a quarter away from the other. So this table was really messed up.
That's so neat.
I know, but you're talking about me here, so okay. Make sense?
Yeah.
All right, everybody good? Great. Now, a couple other problems that come from this section. Okay, we got what, 3 more? We're probably only going to do 2. All right, a little bit of a word problem. Actually, a couple word problems. I know, I'm evil. Okay, I know. All right, solving quadratic equations. First up, find 2 real numbers with a sum of 6 and a product of -55, or show that no such numbers exist. Nestor.
11 and -5.
Well, thanks for ruining my example.
Sorry.
That's correct.
That is correct, I know. Okay.
Those are fun, I like.
Hang on. Let me. Okay, if we want to play that game.
Oh yeah, bring it out.
All right.
I don't like this.
Wait, how did
Yeah.
Is there like an actual way to do that?
There's a 100% actual way to do it. I will.
Yeah, let's see it. Come on.
Two numbers. Which means how many variables?
2.
2. Define them. X and Y. Very good.
Let's see it.
Okay. The sum of those 2 numbers is what?
6.
6.
Product
The product, which is how am I going to write that?
XY.
X, Y. Good job, Asaf.
is big.
55. All right. Now.
So you can't do elimination
Right.
because it's not a plus and it's a plus and a multiplication.
Exactly. So you got to do what?
You gotta put them together. I don't know.
That's some check.
No. You got to do substitution.
Gross.
I know, okay? But, here's where you need to be careful, okay? In your calculators, you're going to put in x's, right? Okay? Right? It's always y equals x squared, blah, blah, blah.
Yeah.
So up here, you need to make sure that you do the first step correctly and solve for y.
Oh.
Okay?
Oh wait.
Here's
Okay.
just,
Are you gonna do it?
yes, I'm about to.
Alright.
Okay, great. So I'm going to solve for this y, which means I'm going to subtract x. Which means y equals -x plus 6. This goes in there. Okay? So it gives you x times -x plus 6 equals negative 55.
I would never think of that.
That's why I'm here.
How do you get that?
How do I get what? I substituted.
Where's the y in that?
I substituted, Garland.
The left equation off the top, you made it equal y,
Oh, I
and then
see.
plugged it in.
Oh, so now you're gonna
You
have
can make
a
your own
quadratic
version.
equation. It's gonna be negative x squared plus 6x plus 55. Now, because you gotta move it over, you gotta make it equal 0. So it's
That's quadratic.
Because
because you have to get the y by itself.
your numbers,
Find the roots.
yeah, then you plug it in. Okay? Now you go to your calculator, go to find your zeros.
Weird.
Couldn't
Okay.
you know that by just seeing whatever negative 55, you have to try to get that?
Yeah, but what if I give you like negative 117 and 3 or 4? You gonna sit there? You gonna sit?
You made
There's
that
only
one
one
number.
number.
You gonna sit there all day?
There's only two numbers that equal 55.
I know. That's why I gave you an easy example to start off with,
And there's probably only 2 numbers.
so we can think about this logically. I can give you jerk numbers, you know, like
Oh, I'm not a
Negative.
fraction.
negative 117 as a product and a sum of 4.
You won't give us a fraction, will you?
Probably not.
That is way too low.
Probably not. But here's the point. Since I probably won't give you fractions, these will probably be nice numbers. Okay? Which means even if that 55, because that plus 55 means that parabola's y-intercept is what? Anybody? Anybody? Thanks for paying attention.
Well, means it's
Oh, it's going to be a max.
It's gonna be a max, but the y-intercept of that graph is gonna be 55. Okay? Like here, watch.
yeah.
Negative x squared.
It's 13 and 9.
We've already figured out the answer.
Plus 55.
Negative 5 and 11.
We're not talking about that.
No, he's not. Negative x squared plus 6x.
You still have that extra.
I know, I see that all now, thank you. I'll just clear it all again.
That's
Negative.
a lot of dells.
X
No,
squared
Algebra.
plus 6x plus 55. Alright, I hit graph. Now, what Osthoff was saying is the y-intercept of that graph is 55.
Holy cannoli.
I know, okay? On your 10 by 10 space, that is the graph. Okay?
So this is one of the jerk ones.
Yeah. And then it goes from here, and it goes way over here someplace.
Are you sure? I think that's
Yes, I'm sure. I've done this before. Now, you can hit zoom, and you can hit zoom out a little, and I can prove it to you. Hopefully it's enough. See?
Oh, because it's upside down.
Right. Alright?
Yeah.
Okay, but that does you no good as far as answering your question goes.
So do you have to do the...
Right? Shh, let me teach.
How do you zip out?
Let me teach. Zoom. 3. Okay? So then all you still have to do, even though it's a big y-intercept,
Just look through the table.
it's still look through the table, correct? Okay, because it's going to move by your x's, right? It's not like it's going by your y's, which is nice. It moves according to your x's. So you go from 0 to negative 1, and you're already down to 48. You're down to 39. You're moving down fairly quickly. See that?
Yeah.
Okay.
Oh, there it is.
And then you get negative 5 as 1. All right. Then you move the other way. Boom! Oh, I did miss it, didn't I? Too far. So you get negative 5 and 11. Okay?
Oh, no.
And those are it. So when you go back to here, you know, add this onto the work that was there because I don't have that anymore. You know, negative 5 and 11. Okay. Now, what would the graph look like when you went to graph it and no such numbers exist came up?
It wouldn't be a graph.
It would be parabola still, but it wouldn't what?
Oh, it'd be like in a quadrant. It wouldn't be like touching anything.
There you go. It wouldn't be crossing the x-axis at all.
It'd be like that.
Okay, right. It'd be no real solutions. It would be like that one. Okay.
Ah,
Make sense?
Well, how do you show
you would just say no such numbers exist, and then you would draw the graph that represents it.
So it just like sketch out.
Yeah. All right. Everybody good? Great. Last one. Not that one. We're going to do this one. Okay, now, real quick, I am going to make a change here real fast, all right? Editing my PowerPoint as I go. Let's make that an H. There you go. I think that's the first time I've ever edited a PowerPoint while I was recording. So, you know, first time for everything. Anyway, all right. A package of supplies is tossed from a helicopter at an altitude of 200 feet. The package's height above the ground is modeled by h of t equals negative 16t squared plus 28t plus h, where h is the initial height and where t is time in seconds after it's tossed. How long will it take the package to reach the ground?
Why did you add the H in there?
I'll tell you why. Most of these are going to be set up like this, okay? Where it tells you most of the parts you need of the equation, it just leaves out this last part, okay? Most of the time, this last part for these problems is going to be whatever other number's there, okay? Which is 200 for this case, right? H is the initial height, helicopter's at 200 feet. Make sense? So 200, like I just edited out, 200 is going to go back into H. Okay? Now, why did I do that? For this reason. Understand the part of the model. Okay? Sometimes, like the one that was just there, it'll tell you 200 feet, and it will already have 200 in the model. At that point, you do nothing with it. Okay? This also goes along with understanding your variables. Okay? T is what? Time.
In seconds.
Okay? Yeah, in seconds. Okay? So T is time.
So would altitude be the height?
Yes.
But don't you plug in the T?
Well, that's what we're trying to find, right? We don't know what T is. That's what we're trying to find. Okay? We also don't know what H of T is over here, right? Because that's a function notation, right? That's just like saying f of x.
Oh, you're going to show us how to find that?
Uh-huh. That's what I do. Okay? Plug 200 into H. So H of T. But remember that this H of T and this H over here are two totally different things, right? Okay? Remember that. All right. Negative 16 T squared plus 28T plus 200.
Oh,
Okay?
so then why is that?
Because once they start to go to model, like since it's talking about height of the helicopter,
Oh, so you
they
just
switch it from F to H, so it's more realistic as to the situation you're talking about. Could they keep it F of T? Yes, 100%.
But that's not the same kind of H as that.
Correct.
Okay.
Okay, Galloway.
so like before you changed it, it was already 200.
Right.
So you just have to use the word problem.
Correct.
Oh.
See, here's where I didn't want the confusion to come. I didn't want the confusion to come from 200 feet. You know how I tell you guys to make sure you use every number in the problem? See, if I left this 200 here, people used to try to put this 200 in through for T, but this is feet, not time.
Right.
Okay, see what I'm saying?
Yeah.
So the way the problem was originally worded, it already used that 200 here. Okay, let me get there, right there.
So then you could just forget about it.
Right, and
Or
then
use it somewhere
you would just
else.
ignore it in that case.
Okay.
Okay, sometimes you will have that happen to you just so you see it. Okay, but most of the time you'll plug in that last variable.
Right.
Okay.
Alright.
No, because we haven't answered the question yet, have we now?
Do we have to graph that now?
Yes, you do.
Or, in this case, could you possibly simplify? Or no, because you have to.
Because then you'd have to do the other side too. Right.
I already guessed.
Okay. Now, here's where the other part means where I'm saying mind your variables. This is still function notation, which is why function notation is nice versus y equals. Because y equals, you almost have to always be in x's and y's. Here, we're in h's and we're in t's and h of t's.
Can't you just do y
But
and x?
but relate them back to x and y. T is acting like what?
X.
X. H of t is Why? So when you look at your graph, keep that in mind. Okay?
So you're graphing to solve it?
Yeah, still graphing to solve it. All right, so negative for now.
Holy crap.
Oh no.
I'll get it up here. Hang on.
Oh, wow.
So negative 16. Remember, we're going to use x now. X. Whoops, missed x.
This one's another in between.
Hang on.
Yeah.
This is skinny.
Oh, come on now. Work. There we go. Thank you. Negative 16x squared plus 28x plus 200. This y-intercept's what?
Y-intercept is in between
200.
200. Thank you, Wags.
Whoa.
All right, now mine's zoomed out, so I'm going to zoom back to my normal, so zoom 6. Going up, coming down.
This one's in between.
Okay?
It's really skinny.
Really skinny, right? Yeah. Got skinny real quick.
Whoa, whoa, whoa.
Hang on, I'm getting there. Calm down. Okay, now, the helicopter then is sitting where? Think about this modeled. Helicopter's at what?
200 feet.
200 feet, which is the
vertex.
vertex. Good.
Yeah.
Okay?
Oh, so 200.
Okay, helicopter's way up here. All right, now, the line this way is basically the package, right? It's the package dropping down.
Yeah.
X is what variable? Did we replace X with?
The ground.
No. We replace it with T.
Time.
Okay? We replace X with T. So this is time. Y is your what?
Height.
Height. Good. So we're looking for where it hits the ground, which in this case is the ground is the
X-axis.
x-axis.
So I was right.
So here's 1 second, it's way up there. Here's 2 seconds, still way up there. Here's 3 seconds. Here's 4 seconds.
Oh.
It looks like it's almost dead between 4 and 5.
4 and 5 is boom there.
Okay? And for now, to say 4.5 seconds is enough accuracy.
But
Okay? Hang on, hang tight, not done yet. Hang tight. Okay? Does that make sense? What's up with this side?
that's what I was gonna ask.
I know. I know. What's wrong with the left side?
The left side is not equal. Oh, wait, no, that doesn't.
It's almost 3.
No.
That's where the
That's
helicopter
negatives.
flew up.
Negative seconds.
Then is that a thing?
No.
No. You can't have negative seconds. Nobody said I'll see you in negative 5 seconds. It's not a thing.
See, that's
It's real
I
life.
already saw you.
It's real life. Okay? So you want to work in the first quadrant up here where everything's positive. Because you're talking about time and feet. Okay? So this is the only one. This is the only one that you care about because it's a word problem.
So that
Okay.
back there's irrelevant.
This up back here on this side is totally irrelevant. Okay?
time out.
There's your homework. All right. Page 167, 1 through 13.
Odd.
Okay?